So coming to the next question, number 11. State and prove Bernoulli's theorem for streamlined flow of liquid in a tube of variable cross-section area. So it is just the proof of Bernoulli. You have to write the statement and then the normal proof. Now coming to the problem. A fully loaded Boeing aircraft has a mass of 3.3 kilogram, 3.3 into 10 raised to 5 kilogram. Its total wing area is 500 meters square. It is in a level flight with a speed of 960 km per hour. Level flight means the height is the same. So change in potential energy will be 0. Estimate the fractional increase in the speed of the air on the upper surface of the wing relative to the lower surface. Fractional increase in the speed on the upper surface relative to the lower surface. We have to find the fractional increase in speed. Fractional increase in speed means v2 minus v1 divided by average velocity. That is fractional change of speed. Okay. So for doing this problem, this is also an application of Bernoulli's theorem. Okay, so change in potential energy term will be 0. That is not there. So we know work done is equal to change in potential plus change in kinetic. That is the basic formula of Bernoulli. In the Bernoulli we will reach a step where change in pressure is equal to P1 minus P2 is equal to half rho V2 square minus V1 square plus rho g h2 minus h1. We have a step like that. So here that h2 minus h1, since it is 0, since it is in the same level, the height difference is 0, so we will neglect that step. So P2 minus P1 is equal to half rho V2 minus V1 square. Only that step is what we needed. Now here how to find the change in pressure. In order to find the change in pressure, you should know one concept, that if the flight is going steadily, it is not going down. That means it is not being pulled by the gravity. So the gravitation force, the force due to gravity is balanced by the force into the upward force. That force is due to change in pressure into area. Pressure into area. The pressure difference, you know the pressure difference into area is the upward force. In fluids, pressure into area is the upward force. That upward force is balancing the weight mg. Okay, so that upward force is delta P into area. So from there you can find the delta P. Okay, and that delta P you will apply in P2 minus P1 in the Bernoulli's theorem. Okay, and also one more thing is given. With the speed, it is in a level flight with a speed of 960 km per hour. So it's in a level flight with a speed of 960 km per hour. That is the average speed. 960 km per hour is the average speed. So that is V1 plus V2 by 2. That is 960. Okay. Now let us come to the problem. So as I said, the downward force is equal to mg. Mg, which is balanced by the upward force delta P into area. So delta P you can find mg by area. Mass is given, g gravity, area is 500, you will get delta P. So that delta P you will substitute in the Bernoulli's theorem. P1 minus P2 is half rho V2 square minus V1 square. So this P1 minus P2 is this value. Now V2 square minus V1 square you can put it as V2 minus V1 into V1 plus V2. So V1 plus V2 by 2, that is the average velocity, which is given as 960. Okay. So this V2 minus V1 is what we need. So V2 minus V1 will be equal to delta P divided by rho into V average. V average means V2 plus V1 by 2. Now here they are asking us to find the fractional increase in speed. Fractional increase in speed means V2 minus V1 divided by the average speed. So V2 minus V1 divided by the average speed. So here P2 minus V1 by average. So RHS also I will divide with V average. So it will become delta P divided by rho into V average square, substituting the values. Delta P we already have. Density is given in the question 1.2. Then average speed, the level speed is given as 960 km per hour. Converting into meter per second you will get 267. Okay. So on substituting all the values you will get the answer as 0.08. Okay. So check.